Hey guys, and welcome. This is the next scripting tutorial. So today we will check out an admin resource. It's for you to check it out with a lot of comments. But first let me show you what you will get. I created 3 commands: car command, teleport, and the NoClip. Start with the car command. You can use any car name, vanilla or custom car, whichever you added to your server. Thing will work. I will go with the smaller version here. Nice.
Yes.
Next up is the teleport command. You can enter the coordinates directly if you know them, or we adjusted it so you can, it will use the marker on the card. So let's put a marker anywhere on the card, up here, and use the teleport command. Will keep my vehicle and place me on the ground. And it will also work without the car, obviously. So let's head back to the city for the NoClip command. Nice superpowers, right? Check out the first video. So next up is NoClip. NoClip is the most complex command. It utilizes key mapping, so the user, you can adjust it however you like it. You can find it in the settings, key mappings, and FiveM. There are all the key mappings available for you. It's coming from Bro Admin. It's all the NoClip settings. You check them all later. So we're in NoClip, kind of slow, and let's speed it up. I think that's the fastest you can go. Yeah, that's it. Let's check out the code. Make sure to check out GitHub. I will put the link in the description below. I uploaded the script here, and you can check out this resource. You can modify it and use it to however you like. Everything is commented and feel free to use it. Let's discuss the code together. Start with the manifest file. We set up game and version as usual. 3 client scripts. One for the teleportation, one for the car, and one for NoClip, and 2 server scripts. So since it's the first time we're using server scripts, we'll just tell a little bit about it. This is run obviously on the client. This is run obviously on the server. So these 2 are separated and they communicate with events. An event is just a string, anything, we will see it in a moment, that is thrown either on the client or on the server, and the other sides just set up an event handler that is catching it and then run code. Alright, don't get too confused. So we have 2 server scripts, one for the commands and one for the identifiers. This will set every user that connects as an admin. Let me show you. But in order for this to run, we will have to make adjustments to the server.cfg. More specifically, we will add this line. This allows our resource, Bro Admin resource, to run the command at principal. That's it. That's everything this line does. I also added this line, maybe for the future. Alright, check out why we need this. Because our server bro identifiers utilizes the execute command and then uses at principal. What this does is, whoever calls this server script, it's called by a client. This is register net event. This marks it as acceptable for client events. So whoever calls this is saved in the source. This is the ID. Maybe you know it from any other server, like 12345, the connection ID. And there's this native where we can get all the identifiers of the given source, of the given player, And this is a list, so we can specify which one we want, and we want the 1 and the 0. It's explained up here. What this does, this takes the current user or the current identifier of the user and makes it extend the group admin. This is the add principal command. All right, just keep this in mind. Everyone that connects will be an admin. This code is called from a client. So let's start with this. It's called from over here, the client bro NoClip. So let's check it out. It's on startup, the basic framework we already saw. And at the first glance, it will just trigger a server event right here with the bro print identifier. This will then obviously set any user that calls this code as an admin. And we need this. So we need that everyone is an admin for our commands. Let's check them out as next. There's a server bro commands file. This just sets up 3 commands. Very easy. Everyone follows the same structure. So I will just go through one. The car command. We register command. This is the native. We specify the name. This is the command. This function gets called when this command is run by any client. There is the end for this function. This true at the end means that it's secured. So this can only be called if the user that is calling this has the appropriate rights for it. Remember, we set the rights in our identifiers when we make the user an admin. And when he is allowed to run this, then this function is called. Then we check for the console because the console is always an admin. And if it's not the console, then it must be a player, and this player gets a client event where we just trigger our string that we start whatever command was used. So on car, on TP, on NoClip. Let's start with the actual client events and the actual spawning. For the car, this is probably the easiest one. We have the event handler that just fetches the event from the server that is coming in. We hand over the arguments that were given by the player. And we just call our self-defined function over here and hand over whatever is at the first place. Pretty simple. Next up, we create a new thread because we want to run in parallel and not consume too much of the main thread. Not too heavily used, but we utilize citizen wait later on. So it's useful. First of all, the given model is converted. Either we define the hash value itself, but this is not usable in game. No one actually uses the hash values. We use any native name of the car, like moments ago where I used the car ASPO. And then we have to convert it. So if it's not a number, then we have to get the hash key. And this is stored in our model. Then we load the model. This is needed to actually load the model. If this is not done, then the car could be invisible because the model is not in the client's memory. So make sure to run this whenever you load anything. I mean anything. All the vanilla stuff as well. It's not always in the memory. If this is not done, then this whole thing is maybe not working and you're wondering. Alright, if this is done, then the model is in the memory and the current client is able to use it. So we just fetch the player pad, and with the player pad we fetch its coordinates. We then use these coordinates to actually call the native, create vehicle, give it the hashed value with the coordinates of our player and the heading of our player. We do not network it, so it's local vehicle in role-playing script. This is used for a shopping or a preview car or whatever. And the mission entity is used for despawning. Yeah, since this is a basic client lightweight resource, we just set them both to false. So it's just a local client, a local vehicle. Next up, we warp our player into the vehicle. That's it. The car is spawned and is working, like you saw before. Next up is the teleport command. This is a little bit more code, as you see. So we just fetch the event, just like before. These times there are 3 coordinates given, x, y, and z coordinate. If they are not given, then most probably we want to teleport to the waypoint. So if they are given, we just call teleport. If they are not given, we check for the blip, for the marker on the card. We will get a waypoint handle. This is common practice in FiveM. We then use this handle to check if the blip exists. If it does, then we get the info, or the info of the coordinates of this handle for this waypoint. And last but not least, we just teleport to the coordinates of the waypoint. The coordinate function itself takes 3 arguments, x, y, z, obviously. We convert them to be a floating number. We do not convert them. This may lead to issues, and you don't teleport to somewhere you don't want to teleport. So this is used to transfer the variables to a floating number. We request the collision at the coordinate, just like before the model. So we load the collision at the coordinate, and then we set the coordinates while keeping the vehicle. But since the value might change, we have to trick a little bit and check if we already reached the ground. We have to unfortunately do this in a for loop, because this only works, this get ground deep, this check for the ground, only works if the area is loaded. And it's only loaded if the player is near. So we have to first teleport it whatever Z was given first. Could be under the map, for example. And then we go from 0 to 1000 and check every coordinate if it fits. So we set the player up 1 every frame, I guess. Yeah, every frame. Check if the ground is reached. This is inside the return value, and the actual ground value is given, send it over here. If the ground is reached, then we again set the current, set the player with the vehicle, and then we break out of this loop. That's the teleport command. Last but not least, the biggest one, the NoClip command. So as you can see, a little bit more code, but we will go through it together. At the top, we have a few global variables, but the word global isn't so true because we use a local. This local means that this global variable is global, but only inside this script. We go quickly back to the fx manifest file. There you can see an order. TP, car, and NoClip. And if you define any value in one of these two, you can use this value in a later one. So for example, if in NoClip, over here, we would just define any variable like any var and set this to any value. Then this any var is accessible in every script that is running after it. So it's accessible in the car and in the NoClip. Just as a side note. So this local won't prevent it, these variables are only available in this particular script. All right, we have our player pet. We just store it in a global variable because it's easier. And then we have a few setter. These are just Boolean values. They are defined by the key mapping. We have the speed that is changing when we also use some of our keys. So pretty easy. Then we have the onStartup function. We saw this in our first script. So if you don't know, check it out. First of all, we call the server event, like discussed before. Then we store our player pet. And then we have a lot of these register command and key mapping. This is one block, so I will just explain one, and everyone follows the same behavior. We have two commands set up and one register key mapping. The key mapping will actually store, like I showed in FiveM, the actual mapping. This will put in the settings. This will work for FiveM. The first string is the actual command name. If we define a plus before it, this will also call with a minus if the key is released. I'm sure a lot of you know the register is control just pressed command we used before, and this is a newer version of it. So this is the key mapping. This is just the name that is shown in the description or in the settings. This is the area we want to set it up in. So we're using keyboard and we use the A key. This is just the default one. This is the first one that is put into the settings and the user can always change it. So this will work with any key. This is a great benefit of it. If the key is pressed, the event with the plus in the front is called. If the key is released, the event with the minus in front is called. What this does, it just sets NoClip left to true and NoClip left to false. So the A key is for NoClip left. Pretty easy, right? Everything else follows the same structure, so I will skip it. Then we have our onFrame. I said in the last tutorial that onFrame is never used to calculate. This is an exception because this is only handled in this particular client, and if we do not do this in onFrame, then the motion becomes flickering and stuttering. Because if the calculation is not done fast enough, it will look kind of ugly. Alright, we have, let's check if NoClip is active. This is done down below, right when the event fetchers set up. We just set NoClip to be active and vice versa. So if it's active, then we deactivate some HUD elements, just so the tab is not working. Then we fetch the current coordinates and the current camera direction. This is a more complex calculation I put down here. Just check it out. It's a little bit mathematically. It just fetches the current direction of the camera where this is looking. We use it to get a smooth fly through the air, because NoClip is working with set entity coords without offset. So we are setting entity coords of the current player in every frame. This is how this all works. If NoClip is active, then we set in every frame new coordinates, and this will then make it so it looks like the player is flying, but actually we also always set in every frame coordinates. We set x, y, z coordinates, and these x, y, z are calculated on every frame. Yes, on every frame. This is needed based on different input values. I will pick NoClip left, where it is, yeah. If NoClip left is pressed, then this value is true. And then we get the heading. This is the current looking direction. And then we will calculate based on this heading, based on the direction the player is looking at, where and how much basically the next coordinate will be. So the x and the y value just depend on the speed and the location of where we are looking. Left and right are pretty straightforward. Forward and back just use the direction the camera is setting. So this utilizes the direction of the entity of the actual player, and this utilizes the direction of the camera. Up and down is even more easy. It just changes the value. And last but not least, the changing of the speed. It's done here. Just change the speed whenever this is pressed. And I set this to the keyboard node, the mouse wheel. So these two are set for the mouse wheel, up and down, and this will change the speed. Alright, that's the code. I hope you like it. Let me know in the comments what you wish for next. And if you don't understand something, just let me know and I will try to clarify. And yeah, if you don't want to miss any further videos, make sure to subscribe and to give this video a thumbs up for the YouTube algorithm. Thank you very much and see you in the next episode. Bye!